Good evening students, welcome to my YouTube channel. Today we will be discussing the water chapter, particularly the solution portion or solution part of water chapter, and we will be discussing the definition of solution, the classification of solution depending upon the many various types, their characteristics, the types of solution and their effect of temperature and their effect of cooling or the effect of heating, and the concentration. So total 4 to 5 topics will be covered in this session. So let's start. First, solution. Now, what is solution? The definition. What is the definition of actually the definition of solution is mainly it is actually a homogeneous mixture. Solution is actually a homogeneous mixture of two or more components. When two or more than two components mix together, then this is a solution. Then solution is formed. So in chemistry language, if we particularly say the definition, that will be the homogeneous mixture of two or more components whose composition may be gradually changed, by changing the relative amount of the component. That means if we change the relative amount of component, then the composition will be gradually changed, and this is a homogeneous mixture. So the definition will be, it is a homogeneous mixture. It is a homogeneous mixture. Solution is a homogeneous mixture of two or more components. It is a homogeneous mixture of two or more components whose composition may be gradually changed, whose composition may be gradually changed by changing the relative amounts of the components. That means if we change the relative amounts of the components, the mixture that is formed of two or more components, that composition will be gradually changed depending upon the changing of relative amounts of component. So this is the actual definition in chemistry language, that what is solution. Basically it is a mixture. Solution is basically a mixture. Now there is a two component of solution. The two component basically it is a mixture of two or more component, but in short it is formed of only two component, that is solution. In solution, the one component is solute and the other component is solvent. One component is solute and the other component is solvent. That means we can write solution equals solute plus solvent. Solution equals solute plus solvent. Now what is solute and what is solvent? What is solute and what is solvent? Now substance that dissolves in the solvent, substance that we dissolve in the solvent to form the solution is solute. That means the substance we are dissolving in solvent is your solute. That means substance, so it is solution, solute is substance that dissolves in the solvent, to form a solution is known as solute. This is solute. And coming to solvent, it is a medium. Solvent is a medium of dissolution that allows you one or more component to dissolve in it. Solvent is a medium of dissolution that allows you one or more component to dissolve in the form of solution. That means you can dissolve one or more component in this medium of dissolution to form a solution, and the medium is termed as solvent. That means it is a medium, of dissolution, that allows one or more components to dissolve in it to form a solution is known as solvent. So the medium of dissolution that allows one or more component to dissolve in it to form a solution is known as solvent. This is solvent. So solution is made up of basic two component, that is solute and solvent. Now suppose if you are dissolving water crystals in water, to form saline water, then if you are dissolving water crystals in water to form the saline water, then the salt is your solute and the water is the solvent and the saline water is a solution. Suppose you are dissolving water crystals. Water crystals is made up of salt. Clear? And you are dissolving water crystals in H2O. That means you are dissolving water crystals which is made up of salt in water to form saline water. Then you are dissolving water crystal which is made up of salt. Clear? Then the water crystal or salt is your solute and the water is your solvent, because water is the medium of dissolution, so water is the solvent, and you are forming saline water, so saline water is the solution. Clear? Next, so this is all about solution, solvent, solute, and this example of solution. Next we study classification of solution. Now if we talk about classification, we can classify solution in various ways. Solution, if we classify solution, it will be basically of three types. One is your binary solution. Depending upon the number of components, solution can be classified into three types. This is a classification depending on the number of components. Clear? So one is your binary solution. Number two will be your ternary solution. And the third one is your quaternary solution. Number third, quaternary solution. So binary solution, it is made up of two components. That's why it is a binary. So it is made up of two components. Coming to ternary solution, it is made up of three components. That is ternary solution. Quaternary solution, it is made up of four components. That is quaternary solution. Clear? So solution, depending upon the number of components, there are three types: binary, ternary and quaternary. But we will only discuss this binary solution because in our syllabus only binary solution is included. Ternary solution and quaternary solution is out of syllabus. Clear? We will only discuss about binary solution. So next, this is about classification of solution on the basis of depending upon the number of components. Solution were classified into three types: binary, ternary and quaternary. Next, generally a solution may be formed by mixing a various ways. If you mix the components in various ways, so depending upon the number of ways of mixing, a solution may be formed. So a solution may be formed by mixing. If you mix suppose a liquid with another liquid, that means if you mixing two liquids, that means a liquid with another liquid, with another liquid. In this way a solution can be formed. For example, suppose you are mixing water with alcohol. Water is one liquid and alcohol is another liquid. So if you are mixing water and alcohol, in this way a solution can be mixed. Number 2, if you are mixing a solid with a liquid, then a solution can be formed. For example, if you are mixing salt in water, that means salt and water, so salt solution or saline water will be formed, salt with solution, or example sugar with solution. So that means salt or sugar solution, that means one component is salt or sugar and another component will be water. Clear? That is liquid. Third category, a liquid with a gas. We are mixing a liquid with a gas, then also solution can be formed. That means a liquid with a gas. For example will be in case of soda water, a liquid and the gas, soda water. Here gas involved is carbon dioxide. Clear? The gas involved here is carbon dioxide. So soda water is an example of a solution which is formed by mixing a liquid with a gas. Fourth component or fourth part, if you are mixing a solid with another solid, that means two solids. If you are mixing two solids, that means a solid with another solid, a solid with another solid. For example, suppose examples are like alloys, different types of alloys where more than one metals are mixed. That means the metals are actually solids. So example will be alloy. So all total 4 categories are there by which a solution can be formed. Number 1 is a liquid with another liquid. Number 2, a solid with a liquid. Number 3, a liquid with a gas. And number 4, a solid with another solid. And their examples are given. Next. So already one classification of solution is done, that is on the basis of depending upon the number of components. Now solution can also be classified as in two types. Number 1 will be solid solution. And number 2 will be true solution. Number 1 will be solid solution and number 2 will be true solution. Clear? Now solid solution is a homogeneous solution. Solid solution is a homogeneous solution of a solid into another solid. That means if you are mixing two solids, a solid with another solid, then a homogeneous mixture is formed, which is termed as solid solution. That means it is a homogeneous mixture, a homogeneous solution of a solid, into another solid, For example, common example are like alloys, metal alloys, where two or more than two solids are mixed together. So metal alloys, generally gold is used in jewelry purpose. It is a solid solution containing gold and small quantities of copper and silver. Gold, where it is used in jewelry purpose, it is a solid, where gold solution, it contains gold and small quantities of copper or silver. That is itself a salt solution. That means if you write gold used in jewelry, gold used in jewelry is a solid solution containing gold. It contains gold and small quantities of copper or silver. Clear? So it is a solid solution. Gold, where it is used in a solid solution, it contains gold and small quantities of copper and silver. So it is a solid solution. Next, number 2, true solution. True solution is a solution in which the size of the solid particle is near about 10 to the power minus 10 meter. That means size of the solid particle is very small. Clear? It is nearly about 10 to the power minus 10 meter. So where the particle size is about, or solid particle is about 10 to the power minus 10 meter, then the solution is termed as true solution. That means a solution in which the size of the solute particles is about 10 to the power minus 10 meter. A solution in which the size of the solute particles is about 10 to the power minus 10 meter. This is your true solution. Now, what is the characteristics of true solution? What is the characteristics? The question is asked. You can get this type of question. So the question will be asked like this: write the characteristics, or write 2 characteristics of salt solution, or 2 characteristics of true solution. So the characteristics of true solution. Number one, it is a homogeneous mixture. Because it is a solution, that means it is a homogeneous mixture. So number 1 characteristics will be, it is a homogeneous mixture. It is a homogeneous mixture. Number 2 characteristics will be, solute particles are very small and its size is about 10 to the power minus 10 meter. So size of solute particles is small, near about 10 to the power minus 10 meter. About 10 to the power minus 10 meter. Number 3 characteristics will be, the true solution is very clear and transparent. It is very clear solution and transparent solution. Number 3 characteristic is, it is clear and transparent. It is clear and transparent. Number 4 is, it does not scatter light. When light is fall on true solution, it doesn't scatter or it doesn't spread the light. Clear? So number 4 is, it does not scatter light. It does not scatter light. And last, number 5 characteristics is, the solute particles in a solution do not settle down. The solute particle, as the size of the solute particle is very less, it will be in moving condition. That means it will not settle down. Clear? The solute particles, number 5 characteristics, the solute particles in a solution do not settle down. Do not settle down. So these are some characteristics about true solution. Clear? So solution, and the 2 types, one is solid solution and one is true solution. Next, another type of classification, we can also classify solution like this. So third category of classification, depending upon the concentration of the solution. Depending upon 2 types, depending upon the amount of solute, or concentration. That means it is depending upon the amount of solute or concentration. Depending upon the amount of solute present in solution. Depending upon the amount of solute present in solution, solution can be classified into 2 types. One is your dilute solution, one is dilute solution, and the second one is concentrated solution. Second one is concentrated solution. Clear? So dilute solution, what is dilute solution? A solution where amount of solute is less than the mass of the solvent. A solution where amount of solute is less compared to the mass of solvent, that is your dilute solution. That means amount of solute is less. A solution where amount of solute is less compared to mass of solvent. A solution where amount of solute is less compared to the mass of solvent. That is dilute solution. Coming to concentrated solution, a solution it is where the amount of solute is relatively more. Than the mass of solvent. That means amount of solute will be more than the mass of solvent. That is concentrated solution. So it is a solution where amount of solute is more. Solution where amount of solute is more is for a given mass of solvent. That means a solution where amount of solute is more for a given mass of solvent. That is concentrated solution. Clear? So solution that is depending upon the amount of solute present in a solution, it is classified into two types: dilute solution and concentrated solution. Another category you can classify solution. That depending upon solute also, that is also depending upon solute. One is your saturated solution, one is unsaturated solution, and the third one is your supersaturated solution. So number one is saturated solution. Number one is saturated solution. Number two is unsaturated solution, and number three is supersaturated solution. So three types, that is saturated solution, unsaturated solution, and supersaturated solution. Clear? Now we will be discussing these three types one by one. So at first, saturated solution. Now what is saturated solution? It is a solution that cannot dissolve any more of the solute. Suppose you are making a solution and you are giving solute in solvent. Now a condition reaches where it cannot dissolve any more of the solute at that particular temperature. Already maximum amount of solute it is consumed. Then this solution is your saturated solution. Clear? So it is a solution. It is a solution that cannot dissolve. It is a solution that cannot dissolve any more of the solute. At a given temperature. This line is very important. You have to mention the temperature. At a given temperature, you must write when you are defining saturated solution, unsaturated solution, or supersaturated solution, because temperature here has an effective role. Temperature here is very effective role over saturated solution. So a saturated solution, a solution that cannot dissolve any more of the solute at that particular temperature or at a given temperature, that is termed as saturated solution. Clear? Now what is the effect if we reduce temperature and if we increase temperature? Reduce temperature means if we cool down the temperature. What is the effect of it on saturated solution? That means effect of cooling. What is the effect if we cool down the saturated solution? What will be its effect? Now at first if we cool down any saturated solution, the solubility of the solid decrease. The solubility of the solid will decrease with fall in temperature. That means if the temperature of a saturated solution is lowered, or if the solution is left open at a higher temperature for a long time, a part of the dissolved solute, that means a part of the dissolved solute separates out in the form of crystal, and the remaining solution is still saturated at a lower temperature. That means the basic thing is that if we reduce temperature or if we cool down the temperature, the solubility of solid in saturated solution, the solubility of solid in saturated solution will decrease with fall in temperature. That means if the temperature of a saturated solution is lowered, or if a solution is left open at a higher temperature for a long time, a part of the dissolved solute separates out in the form of water crystal, and the remaining solution is still saturated, but it will be at a lower temperature. That is the effect. The solubility will decrease. Clear? So we will write if the solubility of a solid, if we cool down the saturated solution, the solubility of solid usually decreases with fall in temperature. The solubility of a solid usually decreases with fall in temperature. Thus if the temperature of a saturated solution is lowered, that means if it is cooled down, or if a solution is left open, if the solution is left open at a higher temperature, for a long time or for a long, a part of the dissolved solute separates out in the form of crystals, the remaining solution is still saturated. But at a lower temperature. So this is the effect if we cool down any saturated solution. Clear? Its solubility will decrease if we reduce temperature, or if we fall down a temperature, and the saturated solution will be the temperature, if it is lowered, or if the solution is left open at a higher temperature, a part of the dissolved solute will separate out as a form of crystal, and the remaining solution will be saturated, but it will be saturated at a lower temperature. Now that was the effect of cooling. But if we increase temperature, that means if we heat the temperature, so what will be the effect of heating on saturated solution? What will be its effect? Now if we increase the temperature, that means if we heat the temperature, or the solution if heated to a higher temperature, then it becomes unsaturated. From saturated solution it will becomes unsaturated solution. That means more solute can be dissolved. You can dissolve then more solute at a given temperature if you heat any saturated solution. That means it will convert from saturated form to unsaturated form. The solution will become then unsaturated if we heat the saturated solution. So if the solution is heated, to a higher temperature, then it becomes unsaturated. that is more solute can be dissolved, more solute can be dissolved, you can dissolve more solute in this solution, So if solution is heated at a higher temperature, then it becomes unsaturated. That means more solute can be dissolved. Clear? So this is all about saturated solution, its effect on cooling and its effect on heating. Now second category is unsaturated solution. Second category is unsaturated solution. So what is unsaturated solution? A solution which can dissolve more of solute. A solution in which more of the solute can be dissolved at a given temperature. That is your unsaturated solution. A solution in which more of the solute can be dissolved, at a given temperature. A solution in which more of the solute can be dissolved at a given temperature, that is unsaturated solution. Next one, supersaturated solution. This is important. Supersaturated solution. This is important. What is supersaturated solution? Now a supersaturated solution is a solution that holds more solute than it can theoretically do. It can dissolve or hold more solute than it can theoretically do at a given temperature. That is your supersaturated solution. So it is a solution that holds more solute than it can theoretically do. A solution that holds more solute than it can theoretically do at a given temperature. That is your supersaturated solution. That means it is a solution at a particular temperature that is more concentrated than its saturated solution. It is a solution in a particular temperature that is more concentrated than its saturated solution at that temperature. That is our supersaturated solution. Clear? So total 3 types of category, that is saturated solution, unsaturated solution and supersaturated solution. Clear? So classification of solution in various ways. We have already studied classification of solution, then that we can classify solution in various types and various ways. Next, concentration of solution. Concentration of solution. What is concentration of solution? So what do we mean by the term concentration? What is concentration? What is actually concentration? Concentration is the amount of solute you are dissolving in a given quantity of that solution. Amount of solute that is dissolved in a given quantity of that solution. That is your concentration. So it is amount of solute dissolved in a given quantity of that solution. That is concentration. Amount of solute dissolved in a given quantity of that solution. That is concentration. Now this concentration can be expressed in 2 ways. One is mass percent, and number 2 is volume percent. One is mass percent and second is volume percent. We can define concentration, or we can express concentration in 2 ways. One is by mass percent and one is by volume percent. So at first let us discuss about mass percent. So here mass of the solid solute in gram present in 100 gram of the solution. Here mass percent means mass of the solid solute in grams or grams present in 100 grams of the solution. That means you are taking 100 gram of solution and you are taking the solid solute in grams. or the solid solute, mass of the solid solute, you will express in grams. That is the mass percent. So mass of solid solute, mass of solid solute in grams, mass of solid solute in grams present in 100 grams of the solution, in 100 grams of the solution. So mass percent is mass of the solid solute in grams present in 100 grams of the solution. It is mostly used when solute is solid and solvent is liquid. It is mostly used when solute is solid solute, that is solute is solid and solvent is your liquid. So it is, this mass percent is mostly used when solute is solid and solvent is liquid, and solvent is liquid. Then this mass percent is used to define concentration. The formula is mass percent formula. So here mass percent, formula of mass percent is mass of solute divided by mass of solution. Solution means solute plus solvent, solute plus solvent into 100. This is the formula of mass percent, and with this formula we can deduce the concentration of the solution. We can deduce the concentration of solution, using mass percent formula. Clear? For example, suppose 10 gram of sodium chloride or 10 gram of salt is dissolved in 90 gram of water. You are dissolving 10 gram of salt or NaCl in 90 gram of water. You are dissolving 10 gram of NaCl in 90 gram of water to make a salt solution. Now what is the concentration of the solution? The question is, what is the concentration of solution? Using mass percent formula. So the formula is mass percent is mass by solute, mass of solute divided by mass of solution into 100. That means here concentration will be using this formula. So mass of solute is here NaCl, sodium chloride is the solute, because you are dissolving the substance, which if you are dissolving something or dissolving a substance, that is your solute. So here you are dissolving sodium chloride or salt of sodium or NaCl, that is your solute. So mass of solute is 10 gram, that is NaCl 10 gram. So write 10 over here, divided by mass of solution. Mass of solution means mass of solute plus mass of solvent. Now solute is 10 gram and solvent is water, that is 90 gram. So 90 plus 10, that is 100 gram. So mass of solution will be 100 gram. So we can write 90 plus 10, that is mass of solvent plus mass of solute. So this is the mass of solution into 100. Now calculate. This is 10, 90 plus 10, this is 100, this is 100. So reduce, that is 10%. So concentration will be 10%. This is the answer. Concentration will be 10%. Clear? Using mass percent formula. So in this way we can easily calculate the concentration of solution using mass percent formula. Next volume percent. Next category is volume percent. Next category is volume percent. So volume of solute, here volume of solute is represented in milliliter and in 100 milliliter of a solution. Volume percent is, here volume of solute is represented in milliliter. So volume of solute in milliliter present in 100 milliliter of a solution. 100 milliliter of a solution. That is volume percent. So volume of solute in milliliter, volume of solute in milliliter present in 100 milliliter or 100 ml of a solution. That is volume percent, that is volume of solute in milliliter is present in 100 milliliter of a solution. Clear? So this is volume percent. It is mostly used when both of them are liquids. That means solute, solvent, both of them is liquid. It is mostly used. It is mostly used when solute and solvent both are liquids. It is mostly used when solute and solvent both are liquids. So formula is volume percent. Formula is volume percent. Formula is same formula like mass percent, but here the mass will be replaced by volume. Here mass will be replaced by volume. All things remaining are same. So in numerator, that is volume of solute. In denominator, it is volume of solution. Volume of solution. Solution means solute plus solvent into 100. That is the formula. That is volume percent. Clear? So if we are taking an example, suppose, so where it is used, volume percent, where it is used when both of them are liquids, that means solute and solvent, both of them are liquids, then we can use this formula. That is volume percent formula. Suppose you are dissolving alcohol, that is 30 milliliter of alcohol. Suppose you are dissolving 30 milliliter of alcohol in 70 milliliter of water. In 70 milliliter of water, you are dissolving 30 milliliter of alcohol in 70 milliliter of water. Here both of them are liquids, alcohol and water, so we can easily use volume percent formula to deduce concentration of the solution. Now the question is, what is the concentration? You are dissolving 30 milliliter of alcohol in 70 milliliter of water. Find out the concentration of solution using volume percent formula. So here concentration will be, the same formula, volume percent formula, that is volume of solute by volume of solution. So here solute will be alcohol, because you are dissolving alcohol in water. So you are dissolving alcohol, that is alcohol is the solute. So substance you are dissolving is your solute. So you are dissolving alcohol, that means alcohol is the solute. So volume of solute, that is volume of alcohol, that is 30 milliliter, and divided by volume of solution. Solution means solute plus solvent. So alcohol, if alcohol is the solute, then water will be the solvent, because you are dissolving alcohol in water. So water is the medium of dissolution, that means it is a solvent. So volume of solution means alcohol plus water. Volume of alcohol plus volume of water, that means 30 plus 70 into 100. So now calculate 30 divided by 30 plus 70, 100 into 100, reduce, it will be 30%. 30%. So concentration will be 30%. Clear? So in this way we can easily calculate the concentration of different kind of solution. Clear? So that's all for today. In the next session we will study solubility. The solubility depending upon the how solubility is, how solubility depends on temperature, how solubility depends on heat, and if we reduce the temperature, what are the effects of solubility. There are different types of solubility and graph. Clear? That's all for today for this session. So thank you.